I think it's just afternoon. My name is Stephen Koob. I'm the Chief Conservator of the Corning Museum of Glass Conservation Department. Today we're going to give you a tour, a live tour of the Conservation Department and show you what the kind of things that we do. But before I get into introducing my staff, I'd like to turn this over to one of our colleagues in the Education Department, and that's Troy Smythe.
Hi everybody, I'm with the Education Division here, and I will be taking your questions online, and then whenever I come down here I always end up with a few questions myself, so hopefully I know we have the people right here who can answer them. So
thank you, Troy. So first and foremost, as I said, I've been here almost 20 years. We have two other staff members who I would like to introduce, and I will be then turning it over to them later. And this is Astrid van Giffen, who's our Associate Conservator, who joined us in 2009. And we have Lianne Uesato, who had joined us just last January, so almost exactly a year ago today. And she's our Assistant Conservator. And behind me, or to my right, we also have Adelaide Hansen, who's our intern from the Netherlands. And Adelaide has just completed her master's degree at Westdean College in the UK. So she's busy working away with us as well. I want to give you a little bit of background of the department here, just so you know. You probably are aware that the Corning Museum of Glass was founded in 1951. So it's a fairly young museum. Well, it's interesting that the Conservation Department is even younger. It's only been in existence really since 1972. 1972 is when we had the summer flood, and there had been no conservator previous to that, but once the flood produced an immense amount of work and of retrieval and treatments that needed for reopening of the museum, Ray Errett, who had been the existing photographer for the museum, was made conservator. He stayed on as conservator until his retirement in 1991, and then I took the position in 1993. I only stayed for 1 year because I found Corning rather isolated at the time, and it was literally, this museum was in one building. And the change that occurred between then and when I returned in 1998 was amazing. As I now say, we have glass in 6 different buildings. We have a studio across the parking lot. We have a separate library, and we have a nice new expanded conservation laboratory. So I started out in archaeological conservation and went from there to the Smithsonian, where I specialized in ceramics and glass. And this seemed like the next best step was to be a specialist in glass conservation. So I'm now entering my 20th year, and when I came back the second time, I decided I wasn't leaving again. So we'll give you a good background as to what we do in conservation. Most of you might be thinking of the fact that glass is basically an indestructible material, except for the fact that it breaks. And so we do need to repair it. Well, there's a lot more of that than what meets the eye, and that's what we're going to talk about today. So we'll talk about things like cleaning, examination of glass, and caring for the collections. We are truly in charge of the care of the collections. We're often called stewards, or in conservation is often called stewardship, because it's a major, major responsibility to take care of over 50,000 pieces of glass in all these many different buildings. So that's basically how we approach things. I want to turn it over to our Associate Conservator, Astrid, and she'll tell you a little bit about herself, as well as introduce the next phase.
Hi, as Steve said, I'm Astrid van Giffen. I've been here just over 8 years now, and before I was here, I actually did my conservation training in Amsterdam, and I came here as an intern as part of that program in 2006. So I was very familiar with this place when I came back.
Can I interrupt you for a second?
Yes.
So we have a lot of different kinds of viewers watching today, including people interested in conservation as a career. We have some young scholars. I understand that Class B5 from Children's Learning Center is watching, and I want to give them a shout out. You want to say hi?
Hi, Karen.
All right, thanks.
Yes. So before I came here, I was also at the Harvard Art Museum, where I studied the Blaschka glass materials models, which I'll be talking about a little bit more later. I'll let Lianne introduce herself and tell a little bit about herself and her.
Hi, I'm Lianne. I joined the lab last year, and my education is in the American programs, the Buffalo State program, where I was a general objects major, but I was always had a soft spot for glass. So I was an intern here in 2013, and glad to be back.
And might I add one thing to Leanne's becoming a conservator here at the museum, and that is 3 years ago we had the very large expansion of the new wing of modern and contemporary glass. And with that installation, the footprint of the museum almost doubled in space in putting glass out. And that is a major responsibility that we've asked Lianne to take care of, and that is modern and contemporary glass.
So what are the big differences between that collection versus the historical and scientific collection that we have?
One is the size. A lot of the pieces are quite large, and also not just glass. So a lot of artists are incorporating multiple materials. And
When you say large, how large?
oh, large.
Large, like size of
room
this
size,
room? Yeah,
kind
okay,
of large.
all right, I got it.
So, I mean, you can see my projects typically don't fit on a table.
Okay.
So I'm
Right, good
spilling
point.
everywhere.
Fair enough.
Go ahead.
Okay, so I will take you over to show you actually a Blaschka that I'm working on. So one of the first things that we do when we get an object into the lab is we look at it. So we examine it closely. We try and assess its condition. This one is broken, as you can see. But we also look at how it was made and what kind of materials, and basically as much as we can find out about that. And one of the ways we can do that is we can use light. So by using a little flashlight, you can see that there's something inside of this glass figure. Actually, let me back up just a little bit and tell you a little bit about the Blaschkas. So some of you may have seen the exhibition here a few years ago that we had on the Blaschka invertebrate models. And this is an invertebrate model. It's a group of anemones. And the Blaschkas were a father and son team. And they made models like this one in the late 19th century, and they transported them all over the world. It's amazing that we still have so many of them left.
Because these weren't just in museums, were they? I mean,
No, they were in museums, they were in universities, and they were really used as teaching collections.
yeah, so it is kind of amazing that
'Cause
we have any left with college
Right.
students getting a hold of them.
Yes. And this was at a time when undersea photography didn't really exist yet. So this was one way to show what these creatures look like other than a flat drawing. The other materials were used to make models, but they weren't as successful as these glass ones.
So is everything we're looking at glass there?
So no, one of the things that makes these models especially difficult for conservation is that they're not just made out of glass. So you can see there's definitely glass elements, but they're all glued together. So this anemone body here, there's actually an outer glass part, and then on the inside there's a glass sleeve that goes all the way around. Maybe a little bit difficult to see, but it's actually painted. So the color is actually on the inside of this one. But some of the other ones, the color is in the glass. So this one has little pink, this has pink tentacles. But this anemone is painted on the outside, and it's green. But you can see that the glass is really, really thin.
Wow.
And all of these tentacles are glued on top of it, on top of the main glass piece. And this would fit on here like this.
In some ways, you can see the object in a more complete way now that it's in pieces than it would be if it was
Yes,
in
we
whole.
can actually learn a lot about an object when it's broken because you can see inside of it, you can see how thin it is. There's a lot of things that you can see when something is broken that you can't see when it's whole. And one of the things I wanted to point out too here is you can see this row or this whole edge of adhesive, so that the glue that was used to put these two pieces together. And we can actually use that and line it up exactly with the piece that goes on it, so we know exactly how this piece would have fit on there. We call that a glue scar.
I noticed you're not using gloves.
That's true.
Do you sometimes, or just?
We do sometimes, but rarely. So a lot of conservators do use gloves. Here at the museum, we feel it's safer to handle glass without gloves because you have a better feel for what you're handling, especially with something this delicate and thin. Yes. And then you can also see that this is very, very dirty. So one of the next steps of this will be to clean it. And while we do wash a lot of stuff with water, this one we can't because it has these other materials. And a lot of them are water sensitive, so the whole base is paper based, and the paints are often water soluble, and the glue that was used to put it together is also water soluble.
So you dry clean it?
Yes, basically. So, well, we dry clean it. We use a really soft brush and kind of brush away the dirt with a vacuum cleaner just to suck up the dirt. And then we might also use a solvent that's a non-polar solvent. So that means it doesn't have any water in it. So that's safe for the water-sensitive materials. And I think Lianne will tell you next about other ways we clean glass.
Well, let me add, though, that one of the things I think that Astrid's been showing you is the fact that knowing the material is one of the critical approaches to any kind of conservation. And this is what we call material science. And so a knowledge of the glass, of the other materials that were used in the construction of this piece, and many, many others, helps us a lot into determining the approach that we're going to have for either cleaning and or conservation.
So the background you end up needing isn't just an ability to sensitively handle fragile materials. You also have a background in what, chemistry? And
yes, a very strong background in chemistry and what we call material science,
okay,
which is knowing how materials behave and how they preserve, how they deteriorate. And cleaning, that takes us into our next.
Okay, come on over to the plastic sink. So like Steve was saying, a lot of our objects can be washed, and this is where it takes place. So we use, for the most part, very soft natural bristle brushes, and the plastic sink helps prevent any kind of scratching or.
can I touch that?
Sure. This one's soft.
Oh, okay. Yeah, so like almost like a soft toothbrush kind of.
We have
deal.
toothbrushes actually
Sure
too.
enough,
So.
yeah. It's like a dentist office.
And paper toweling. It's a very soft dentist office. And there are two main reasons we wash the glass, and the first is just because it makes it sparkle. So you can see in these images, this is an image before any kind of washing. See, it's kind of hazy. And then after washing, it's just bright and sparkly, like it should be.
Some of those look like not glasses made in ancient times, but look more contemporary. What ends up sticking to a contemporary goblet, or aside from just fingerprints and things like that, that you would?
If it's being used, there's all kinds of things, food and all that kind of thing. But like if we were looking here, the deterioration sometimes comes from inside the piece, so the composition of the glass. So in this case, and in the case of the photos that I showed, the alkali from the glass is migrating out and giving that hazy appearance. So washing the glass, that's a good segue into point 2, which is we're washing it so to keep it healthy, because once it gets past this stage, it sort of attracts more moisture to the surface, and that sort of keeps the process going.
So you're saying it's not necessarily just only things that kind of come from exterior sources onto the glass,
right?
But like glass itself
Exactly.
is leaching impurities. Okay.
Yeah. So, as Steve likes to say, glass should be washed at least once in its lifetime, even given the best stewardship, the best kind of environmental conditions. Still, the problem is inside. So
Once, but not more than it needs to. Is that what's the max?
Yeah, I mean, part of it is just caring for it. It's what it's exposed to. I mean, the galleries upstairs have carpeting. We also have lots of guests, exceeding 400,000 guests a year. All this brings in dust, dirt, fibers, pollution. Years ago, we used to say it was cigarette smoke. Now, at least, we don't have that, but still, there may be residuals of those on some glasses. So washing that off kind of resets the clock for the glass and keeps it quite stable.
I have a question from online. Have you ever broken something while conserving it?
what a good question. Yes. Sometimes old repairs are not completely obvious, and they just give way in the least convenient times, usually. So that's why we have nice padded surfaces to work on.
Soft everything.
Yes,
Yeah.
soft everything, exactly.
So does
Yeah.
that was at least a good repair in terms of aesthetics, that you didn't notice it, or did you notice it and just didn't know that it was, whether or not the adhesive was holding or not?
I thought it was a little more stable than it was.
Okay.
I overestimated.
I hope you didn't get in trouble.
No, well, it broke in the right place because
Okay.
we do know how to fix it.
In fact, we handle an incredible amount of glass every year, from working with exhibitions to helping out the photographers to also cleaning things for publication or loans. I mean, we have a very, very active loan schedule that we have requests for things. So we handle a lot of things, and that's a serious risk. That's a serious, serious risk. And I think we have an incredibly good track record for not breaking things. And it's a part of that is learning how to handle glass properly. And as Astrid already brought up, is we like to generally keep clean hands and handle things with your bare hands because you have a better feel for it. But weight can be a big issue. Some of these pieces can be extremely heavy and difficult to handle. And so we often, again, would seek out some help if we need it. But I like to, the sink is like a little more user-friendly than
Yeah, I
than
want a
stone-
plastic sink.
than a stone sink or a metal sink. But if we can put it in the sink, it's more stable, and that way it can rest in the bottom of the sink, and then we can wash it safely around it.
And
Where
just
does-
to give you an idea how rare it is to break something, I can remember breaking things twice. Once when I was an intern and once when I was sick. So if you're handling glass when you're sick, it's not always the best idea either.
You're just
so.
not at the top of your game when
Exactly.
you're sick. Yeah, that makes sense.
So that's in about over 10 years, so not too bad.
Well, related to the idea of breakage, this is another question from a viewer. Do we repair just the museum's collection or outside collections as well?
As a matter of fact, we have been really asked only to work on our own collection. We have done outside work occasionally for several reasons. One, if it's something that's being loaned to us for an exhibition and it needs better repair to go on exhibition. So we have sometimes we've agreed to that. That is very true for the Blaschka Flowers show that we had over 10 years ago. And some of those pieces came from storage in Harvard, and they were not in the best of condition. And so we had a collaborative project with Harvard to jointly treat or retreat some of those pieces so they could be exhibitable. The other thing that we occasionally take projects on for is for our interns, because they're avid and eager to do as much glass repairing as possible. The more projects, the better. And so we occasionally take on some outside things, and we do not charge for that. It's just a nice, courteous thing to do to someone who is a collector or a private person who's has a name, a piece that they very dear to their heart, and we just do a simple treatment for it.
Great, thanks.
And I think next we're going to have Astrid's going to talk more about examination in the interest of following up Lianne's discussion of how glass can possibly deteriorate.
Yeah, so one of our most used tools is the microscope. We use it for examination. We also use it for treatment.
That's right.
We actually have two. We have one on a stand that we can use for larger objects as well. And I just wanted to show you this piece. This is a decanter from about 1910. And it's actually really interesting because it's deteriorating. But what I want to show you is what that looks like under the microscope. Give it a minute to color correct itself. So if you can see where the little blue arrow is, that's actually the surface, the outside surface of the glass. But then when I focus on the inside surface, you can see this vast network of cracks. And this is what we call crizzling. And in this case, it happened because of the composition, like Lianne was saying, but also because this is a closed form. It's a decanter. So at some point, probably it was used, it was rinsed, it was cleaned out, a drop of water was left in there, and then the stopper was put back on there. And so inside became very, very humid. So it accelerated the deterioration process. And this is what that looks like. So it's just a network of these really fine cracks.
So just a little bit of water was enough to crizzle, is that what you called it?
Yeah.
Kind of crizzle the entire inside of the decanter.
Yes.
Because I noticed the top is not crizzled at all.
No, and the outside, if we go back out. If we go back to the outer surface, you can see it's dirty,
Yeah.
but you can't see, there's no cracks in the outside at all.
Wow.
So we think of glass as a very stable material, but actually one of the things it's most sensitive to is water, which is kind of interesting.
Yeah. Water. Good old water.
Yep.
Who knew?
All right, so next I'm going to show you another tool that we can use to learn about the composition of glass. So we'll come here, and for this part we have to wear our safety glasses.
Thank you.
And Troy, can I just have you turn off the light for me?
Yes. I can't get my glasses to fit.
It's a little bright in here. Okay, so we have two different sources of UV. So we have shortwave and long-wave UV, and they can tell us different things about the composition of a glass. So this is a piece of Steuben. We know that it's a high-lit glass. And if you look at it under the shortwave, it's this very typical blue color.
High lit. What's it?
High lead.
High lead.
High lead. So it has a lot of lead in the composition. Under this one, you really just see the purple reflecting off from the lamp. So this is what we use the shortwave for, is we can see if there's lead in the glass, which can be very useful.
But that doesn't show up with. So this is a short wavelength of light.
Yeah.
And it shows up there, but it doesn't show up the longer wavelength of
No,
ultraviolet light.
no. So the long wave shows us other things, which I will show in a minute. So lead is something that we can detect with UV. The other thing we can see with UV is uranium. So this uranium glass is a very nice bright green color.
It actually looks radioactive.
Yeah, well.
Not dangerously so, I'm assuming you wouldn't be holding it barehanded.
The amount of uranium is very, very small,
Okay,
and
good.
it doesn't come
We're
out of
not
the
in
glass,
danger.
but you can really see it under the
Wow.
long wave.
That's heading into Ghostbusters territory.
Yeah. And the other thing we can see often is something that's in a lot of colorless glasses. So most of the glass in the world is the composition of, it's called a soda lime glass. It's has soda, so silica, silica, soda, which is the alkalis, and lime, which is calcium. But naturally, that often has some kind of impurities in it, which might give it a little bit of a greenish, bluish tint. So a lot of the Roman glasses that you can see have this kind of bluish, greenish tint to it.
How come they couldn't control the amount of soda or lime?
Well, they did. So they controlled the amount of soda and lime that went in the glass. But along with that, there were impurities such as iron that just came with their source material.
They just didn't have bottles of sodium sitting around.
No. No, I mean, it was a lot of, it was made from natural materials.
Plants.
Yeah, plants and things like But later, it was discovered that they could add manganese, a small amount of manganese, to kind of counteract the iron and the other impurities in there that give it a green color, to kind of negate that. And so that's what you can see in this glass. It's this nice little yellow color.
Oh. So the yellow is the manganese?
Yeah.
Okay.
So that's the manganese that we're seeing.
So it's not just you have to sort of have a chemistry background, you also have a little bit of a physics background.
Yeah,
'cause we're
definitely.
talking wavelengths of light and
Yep. Yep. Yeah, there's quite a bit of science involved.
So how does one become a conservator?
Well, there are generally two ways to do it. The most common way nowadays is to go to a conservation training program. As Steve mentioned, that we do internships here as part of that. But there's so the conservation training programs are usually grad school level. There's 4 in the U.S. now, I believe.
Just 4?
Yeah, so there's 4 in the U.S. Most of our interns actually come from European programs. And there's a slight difference in it. Most of our interns come from Europe because in Europe, conservation students can pick a material to specialize in. So I specialized in glass and ceramics. And in the U.S. programs, people are trained as general objects conservators.
Oh, okay.
And then later, like Lianne did, can specialize in glass, but that's generally not
Has to
chosen
build on
from
something
yes,
else
yes,
first. Okay.
Yes, yeah.
Okay. Cool.
Yeah. I'm going to hand it off to Lianne now. Who's going to talk a little bit more about documentation.
Yes. So one of the good questions might be, where does all that information that we gather from examination go? And we are very, very interested in documenting everything we see when we examine an object. So what is it made of? What's been done to it previously? And where is it from? All of that good stuff. So all of that gets written down in a couple of reports, condition report and a treatment report at least. And photo documentation is another aspect of this process. Photography of a treatment before, during, and after. So this one is before. And after it gets reassembled, it would get another picture. And that is a way of documenting what we did as part of the history of the object.
So it sounds like you're saying that it is that, I mean, in my case, I work a lot in the galleries with people, and I work a lot with the finished version of your work.
Right.
But that beginning part is important for what reasons?
So that sometimes a conservator in the future can know where the breaks were.
The breaks are, okay.
You know how I was saying earlier,
right,
my repair.
Yeah, that would have been good information.
Right,
to
it would have been good. So I guess we operate within the AIC Code of Ethics, so part of that is just being transparent about what we're doing, so that not only a future conservator, but just for the museum's records.
So in terms of ethics, that's not a word I typically see or imagine being associated with conservation. What does that mean exactly for you?
For me, that is...
Or your department, I guess.
It is, I think, along the lines of what Steve was talking about earlier, stewardship, just guidelines, proper guidelines for stewardship, like being transparent about the materials we use and our intervention,
right.
In the process of, an object's life.
Yeah.
And that.
So the idea is preserving and making sure that people who might have this to take care of this object in the future have all the information about it, whereas,
right.
if it's a gallery situation, it's different, and they might be not as concerned with
right.
kind of what's happened to the object before.
And everything that we do should be detectable. So
yes.
what we're doing is not misleading, is not meant to be misleading in any way.
Okay.
Yeah, it's meant to maybe integrate and not be distracting, but not.
Yeah, so you have sort of an education role as well. Yeah.
I guess you could say that.
Yeah.
Yeah.
Educating the future.
So once an object's done with this aspect, we pass it on to the treatment part. Steve will talk about that.
So this would be the before treatment, and so we also document it, on paper or in digitally. So so that we have records that we can refer back to decade after decade, because it's one of the most useful things, as Lianne did say, for future conservators, so they'll know what adhesive may have been used, what cleaning materials might have been used in case there is some change in the piece itself. One of the key things I think about ethical approaches to the work we do is the fact that you should not do any more damage to a piece.
Okay.
And so we're very conscious of what adhesives we use, what cleaning agents we do use, so that they're not going to do any more damage now or in the future to that piece.
And kind of preventing future damage if somebody else
Exactly.
handles it too. Yeah.
So I want to talk just briefly about, because it's a very complex subject, but I want to talk about the two major adhesives that we use for the repair of glass. Glass does break. It's a solid. It's an amorphous solid, but it can break into very small, tiny pieces, very sharp pieces, and repairs are very difficult. It's certainly one of the most difficult materials in, I'd say, the field of conservation, and has been mentioned as such many times, to repair. We have introduced in the last 25 years an acrylic adhesive for the repair of glass. This is a very stable material. It's very similar to plexiglass, but it's in a liquid form. It's also very similar to the type of adhesives you can buy in a hardware store. It's just much, much better quality. And we don't even know how long it might last, but we do have some estimates from tests that were done in the 1960s and 70s, is that it could easily last for several hundred years.
So that was created here?
No, I actually brought this with me.
Okay.
But I designed this to be put into adhesive tubes and designed it specifically as a thinner adhesive for use on glass.
So it's a
Because glass can be
original.
Yeah, glass can be actually very unforgiving in how the joins go back together, and so you need really a thin adhesive as possible. So this is nice because it's more user-friendly. It's simply made up. It's an acrylic, and it's made up in acetone. So which acetone is a fairly harmless solvent. It's what you use for a nail polish remover, and just that in the tube here produces an adhesive that we can use on almost all our glass. We don't use it on all our glass because it has one minor drawback in that it leaves little air bubbles in the join line. So if we're doing a really clear glass, a really beautifully clear glass, we would probably not use this because you would see air bubbles throughout the repairs. But we do use it otherwise for ancient glass, for Islamic, opaque glasses, anything that we can pretty much get away with, so that because it's stable and it's reversible. That's another key thing in the ethical approach to these things. We'd like to have most of our treatments be reversible if for some reason the treatment needs to be redone in the future.
So you don't do anything you can't undo.
Right,
Okay.
right, exactly. And occasionally there's the rare possibility that another piece might show up if it's an archaeological repair. So when we're not using the acrylic adhesive, we use epoxy adhesives. And there's a variety of these available on the market. We use very high grade conservation quality epoxies, and we have different types that we can use to match the different types of glass that we have. So here's a piece that actually was repaired with an epoxy, and you can't even see a break. It's almost completely invisible repairs, and that's pretty hard to believe because we actually have, again, the before treatment photograph of what it was broken into. And so
Boy, that wasn't just broken a little bit either, was it?
that wasn't just broken a little
Some
bit.
real damage there.
And so actually the result of this, I can't even take credit for this, was done by one of my interns a year ago.
Wow.
So a nice result. So the glass is handleable. For those of you who are at home or are collectors, no, we would not certainly ever run it through the dishwasher. A repaired piece of glass is sensitive, again, to handling and to eventual, storage and care. So we have a variety of examples out here on the tables. You can see these pieces opposite me are being repaired with this acrylic adhesive. Some of these here have been repaired and have what we call loss compensation using epoxies. The one major drawback of the epoxies is the epoxies tend to yellow over time. And so you'll see that also on this flask over here, that the plastic repair has yellowed in actually a very short time. But we need to use these plastics, we need to use these synthetic adhesives because we really cannot refuse glass. It's one of the most difficult things to do because once the glass is made and it's annealed, it does not like to be reheated. Reheating soda lime glass makes it expand 30% by volume, and it can easily explode.
I'm trying to imagine you doing, even if it weren't so hard, all that many pieces would eventually multiply the amount of margin for error.
The margin for error is great. The trying to hot fuse pieces of glass together is singularly difficult. And so, yeah, it takes an incredible amount of skill to work with adhesives, but practice makes perfect, and that's why we love having interns here who are willing to go the 2 or 3 months and work on various projects. The microscope is, again, a very, very useful tool for assembly of glass because you can, even at low magnifications, you can really see precisely what you're doing. And every join needs to be exact. And the first joins are the most important because if you get the first join wrong, everything else is going to be wrong. But you get the first few joins correct, everything will then lock into place afterwards.
So it sounds like the end goal isn't to make it look like it made when it was first made necessarily, because you know that epoxy is going to turn yellow, and that'll still, some pieces of glass are so important we'll still put it in the gallery.
Right, correct.
Okay.
No, it's basically to bring it back to as close to possible as an original piece. And that way it's not going to be in a shoebox sitting in storage.
Right.
And it can be appreciated again as a unique piece that was made in the 19th century. And yes, as you say, go back on display where the public can see it and understand that it's part of our American history, because this is a nice American piece. So this, not all glass repairs this well. This is almost singular because of the fact that it's pressed glass, and so it's got a lot of decoration on the surface that kind of hides the breaks. Really, really clear glasses, unfortunately, don't hide all that, and so it's very, very hard to hide all the repairs on glass.
I had a question from online viewer. How long did it take to conserve the candlestick we saw?
So I don't know if she kept records on the amount of hours, but I usually ask my interns to do that. But she worked on this for about 3 weeks, but not just by itself. The problem with doing repairs on glass and joining glass is one single join may take, an hour to set. If it's using the acrylic adhesive, for the epoxy, it may take 8 hours to set. So you may only be able to do 1 or 2 joins a day. So over a period of time, it may take several months or several weeks, but the elapsed time is only a few hours. Mm-hmm. So in this respect, I guess she would probably have spent 10 to 15 hours on this. We could look it up and see, maybe.
And then worked on other projects when she was waiting for things to go dry up.
Right, exactly. So that's why we have all these multiple projects out, because it's prudent to not waste your time just waiting for the adhesive to set.
Yeah, watching glue dry.
Watching glue dry, exactly. So anyway, I think that's about all I can think of for adhesives.
There's a couple of more questions actually that have come in. Does the thickness of the glass matter when conserving it?
It does. I think the thicker the glass, the harder it is to work with. Are we?
Yeah, we'll join you for questions.
Can join you for questions here. Yeah, so I have done some very thick glass. One of the problems with joining thick glass is with the acrylic adhesive, it takes much longer time to set because it takes a long time for the acetone to evaporate out of that thick glass. So thinner glasses actually can be repaired much, much faster than thicker glasses. It also limits the amount of ways we can repair glasses, because you don't always, I didn't mention the techniques of repair. We often repair glass what we call piece-by-piece assembly, one piece at a time, building it up from the bottom up and ending literally at the top. Other types is glasses can be assembled by taping them all together first and then introducing the adhesive as a liquid and having it percolate into the joins, or what's called wick into the joins by capillary action. This is almost impossible to do with thick glass. So anything over maybe of a quarter of an inch thick, it's virtually impossible to do this because it's just too much of a depth for that adhesive to wick into.
Oh, interesting. Another question, does glass lose color with age?
No.
Does not.
It can change color because of the sun. So it's what's called solarization, and again, it's the manganese we were talking about earlier. It can changes it changes state, the electrical or the chemical state, and it becomes something that gives color instead of hides the color.
So the ingredients are the same,
Yeah.
but the effect is different.
Yes, yes. But other than that, glass itself does not really change color. Things on the glass could, so the adhesives, and like the Blaschka materials, because they did use paints as well, those can change color.
And so I noticed some of the ancient glass that was originally clear sometimes has an iridized or rainbow-like
Yes,
surface.
true. That's a good, yeah. So that's actually deterioration, and that's in ancient glasses. What you see there, we call that weathering, and it's really microscopic thin layers that trap air between it, and so it's the light reflecting off of these different layers that
On
causes
top
the.
of the glass.
Yeah.
Okay.
Well, it's in the glass. It's the glass surface changes, so the glass actually changes chemically.
Another effect of water, and again, archaeological burial, almost all glasses are exposed to water seasonally, and it leaches out a small amount of alkali every season or so, and leaving behind these very thin silica layers, which is what Astrid's talking about.
Do you clean rough glass surfaces differently from smooth surfaces?
Talk to Lianne here, who's been cleaning a lot recently.
Cleaning a lot. Yes and no. It really depends on the piece, especially how well adhered the surface is. And sometimes there's, I've been seeing paint or some kind of coating applied to the surface, and in that case, we wouldn't necessarily just go ahead and wash it. It would probably be a dry cleaning, much more like the Blaschka models.
Okay.
So like the example of the cut glasses versus like a smooth glass, we might use a wet paper towel or a soft paper towel to clean the smooth surface, whereas we might use the brushes to clean the cut surface.
Okay. Speaking of the Blaschkas, I have a question about the adhesives they used. Did they use a hide glue?
Yes.
They
So
did.
they used basically whatever they wanted, but a lot of the adhesive they used is an animal-based glue, so like a hide glue. They also used waxes and shellac and natural resins and all different kinds of things. So.
Can you repair silver overlay?
Not very easily. As a matter of fact, it kind of falls out of our realm of treatment. I did not mention, although Astrid did, is that we are primarily objects conservators. Objects means three-dimensional pieces. So we don't do work on windows, we don't do work on stained glass, where you often see a lot of silvering and what we call grisaille or coatings. No, we would probably pass that on to either a paintings person or to a stained glass person. Regilding or resilvering is an art unto its own, and I don't know that it's used very much in restoration techniques, except for maybe possibly stained glass and some gilt framing and things like that. So I'm not sure we would do it to glass. I think we would accept it as just a damage or deterioration to the glass.
And I have a question about epoxy. Wouldn't epoxy work for really clear glass since it has the same refraction index? You might want to also, for the people who may not be familiar with refraction index, talk about that.
Yeah, so the refractive index is how the light passes through the object and and is not blocked. So, you know, the rock crystal is an extremely, extremely clear, pure silica that has a very low refractive index, whereas lead glasses have very high refractive indices, and the difference between those is visual. It's been published extensively that you should be able to see the difference between a soda lime glass and a lead glass just visually, and usually it's the fact that it's just brilliant. So we often call cut glasses brilliant glasses. Because they just shine. The light goes through it and it just looks, you know, so brilliant. So we do have actually different levels of epoxies. We use 4 different types of epoxies fairly regularly, 3 of which have a fairly high refractive index or indices, and 1 that has a lower refractive index. So we use the lower refractive index, which is Hextol. It's commonly known in the conservation field, and it's been in use for almost 50 years. For our lower refractive index glasses, which are soda lime glasses, potash glasses, mixed alkali glasses. And then for the higher refractive index glasses, which is virtually only lead glasses, we use the other epoxies. And we can get a very, very nice, you know, optical match. So that also helps the join line to almost disappear.
Cool. We'll end on a fun question. What was your, well, they're all fun. Who doesn't want to hear about Hextol? What was your favorite project in your career so far? Because you're still in it.
I think my favorite one is actually one I just finished. It was the Blaschka model. It was a squid. We named him Squiddy. He was on view until just last month at the Johnson Art Museum at Cornell, and he just had so much personality.
Mm-hmm.
It was really fun, but he was also really tricky because, so if you can imagine a squid is kind of a long tube, and he was broken kind of in half, but on the inside, an area where his arms attached, there were a lot of broken pieces in there that I had to try and glue together, even though I couldn't actually reach them. So I glued pieces, the pieces of glass to wooden skewers to kind of glue it in there.
Wow.
So I really like the projects where I have to get very inventive.
Yeah.
So that was one of my favorite
You did
ones.
it for Squiddy.
Yes, Squiddy.
What about you, Lianne?
Ooh, that is a good question. I think it's between 2 dioramas, one that I did when I was a student at Buffalo State and one that I did here. And these dioramas are basically lamp work for itinerant lamp workers would come through and make some curios, and people would put them in domes. And fortunately, they put them in when they put them in domes and they broke, all the pieces are there.
Oh, contained in
Yes,
the dome.
yes. So it's just finding the pieces and putting them all back together. But
Cool.
it's rewarding, and it's kind of nice to, I don't know.
I love a good diorama.
Exactly.
How about you, Steve?
Oh, probably too many to name, but as Astrid said, some of the more challenging ones where you have to work hard to assemble a piece. So there's been pieces we've put together out of almost 100 fragments.
Wow.
But speaking of dioramas, one of my favorites in the museum is one that everyone should look up, and that's the what we call the Corning Theater. And it's actually a mechanical theater that dates to about the 1750s. And it's made with, again, a lot of lamp-worked or flame-worked pieces. And it came in previously repaired and damaged. And I had to restore the heads of the little tiny swans that were swimming in the little pool of glass. I mean, at the bottom there's a little fountain, and the little pool was made up of a mirror that reflected back, and it looked like just water in it. And there were 4 swans swimming in there. Well, 3 of the swans were missing their necks and heads. They had been broken off. And the curator asked me, "Can you please fix them?" And I said, "No, they're too small. They're the size of my little fingernail." But eventually I gave in, and yeah, through the techniques that we use and teach of casting and molding, I replicated the 3 swan heads, and now they're complete again, and they look whole. And it's on display. It's one of the few pieces, the only piece, I think, in the entire museum that we keep in the dark. We keep it in the dark because it has a lot of light-sensitive material on it.
And then there's a button
and there's
below it that you
there's
can
a
turn on
button,
the lights.
yeah.
I've seen that.
There is a push button that you can press, and it lights it up just like a theater.
Now I'm going to look for the swans. I think there's so much going on in that piece. I've never noticed the swans. Great.
All
Thank
fun
you
things.
guys.
Yeah.